Grab your hat and let's go! Hello there, everyone. Welcome back to Positive Comedy. It is now day 3 of our LeetCode challenges, and I'm actually really excited to get this one started. So, without further ado, we're going to go ahead and get into it. So we're going to work on the minimum bit flips to convert number challenge. Also, before I completely dive in, I just wanted to mention that there are solutions for the 2 other problems that we worked on earlier this week. Those are linked in my Discord channel under the LeetCode channel, then they're also in the YouTube video version descriptions and the comment section. All right, and it's good to see you back, chat. Welcome back. Okay, so now it's time to attempt this in 30 minutes. This will be the last LeetCode stream of the week. However, we will have another stream tomorrow with Roblox Studio coding and Minecraft from 6 to 8 PST. All right, so let's go ahead and get started. All right, so this is the minimum bit flips to convert number. This was the daily challenge for Wednesday, which is today. It says a bit flip of a number x is choosing a bit in the binary representation of x and flipping it from either 0 to 1 or 1 to 0. So, for example, for x equals 7, the binary representation is 1, 1, 1. Okay, so if there's anyone who hasn't done binary representation before, this can get pretty confusing, but essentially what this means and what it's saying is... Oh. Give me 1 second. There we go. Okay. So that was the number 7, right? So all numbers can be represented in binary notation. And it's a really, really easy way for the computer to understand what a number exactly is. So the reason why 7 in binary representation is 1, 1, 1 is because this 1 represents 2 to the power of 0. This one represents 2 to the power 1, and this represents 2 to the power 2. And if you add those up together, then you've got 4 plus 2 plus 1, which is 7. So if we go back to the problem, okay. Then, so essentially what this is doing is we have a start and a goal, and we have to see how many binary flips need to happen. So for 10, let's go ahead and write that down real fast. Okay. So that one should be, let's see, let me see if I can remember. So 2 to the power of, 2 to the power of 3, which is 8. And then we won't have 2 to the power of 2, but we will have 2 to the power of 1. So that's 8, 9, 10, 0. Okay. So that's going to be 8 plus 4 plus 2 plus 1. Wait. I totally messed up. Give me a second. That was hilarious. Wow. I totally just went on autopilot. Okay. 8 plus 2 equals 10. Okay, so we have 1, 0. So this means that we would need to flip, if we want to make 7 to 10, we need to flip this one, we need to flip this, and we need to flip this, which is why we would end up returning 3 in the end. All right. Oh, I have a really good question in the chat. Let me go ahead and put it up on the screen for everyone to see, because this is actually a really, really good question. Okay. Well. Okay. So the question is about reified. Welcome back, by the way. Do you know about binary representation of -3? Ooh, that is a fantastic question. Chat also says, once I was faced with that question on an interview. Ooh, you know what? We can go over that. So... and you know what? I'll check my knowledge after it too. I'll go ahead and attempt it myself as if I'm on an interview, and then we'll go ahead and check my work. So I will admit I don't work with negative numbers too often, but it does happen sometimes. So if I want to do -3, which sometimes it just takes a bit to load. Okay, so if I had -3, so there is something to note. There is something called a sign bit. So essentially, if I'm remembering this correctly, what you would do is you would do binary representation like normal. So if it was 3, it would be, I think it would be 1, 1. And then, of course, there's 16 bits, so then you'd have like a ton, you know, you'd have a ton of zeros to the left direction, and it's just like that with the other ones too, up to 16 numbers. And let me just double check. So yeah, that's 2 to the power 1, 2 to the power 2, so that's going to be, yep, that's going to be 3. Okay, but there is a sign bit, which, let me just move this over a little bit, which will tell the computer whether it is a negative number or a positive number. So since this is negative, there should be a 1 at the beginning of the 16 bits. But let's go ahead and double check that. All right, this is where ChatGPT is useful to check my knowledge. That and Google. Okay. Perfect. All right. What is -3 in binary? Great question, by the way. I'm really, really glad you asked this. This is good for us, for all of us to practice. Okay. Honestly, it's bringing me back to my computer architecture days, and that has been a little over a year. It's hilarious. I might actually need to refresh this page. Oh, nope, it did it. I was just being impatient. Okay, perfect. Okay, I was wrong. I completely failed. Okay, so okay, I was close, but not quite. Oh, okay, so I was right with the +3 representation. However, I did not do 2's complement. That's hilarious. Okay, so essentially is you have to flip it all to get the 2's complement in the end. So let me just finish reading this though, just to make sure that this is actually right. Because sometimes you want to take ChatGPT with a grain of salt, because ChatGPT is not always right. Okay, so I don't know why I thought that was so funny, but it was. Okay, so let's see. The leftmost, oh yeah, the leftmost bit 1 indicates that the number is negative. And 2's complement, a leading 1 means the number is negative and a leading 0 is positive. Okay, so that's what I was talking about before. But I did leave out the 2's complement part, which I guess makes sense. Okay, so in 2's complement, the most significant bit acts as a sign bit, which is the one I was talking about earlier, and the value is interpreted based on this bit. So this is the binary equivalent of -3 because of how 2's complement is designed. Interesting. Okay. I guess that makes sense. I think I definitely just left out 2's complement. To be honest, I want to look deeper into why you would use 2's complement, because I remember I was taught this, like when I took a college class and we went over 2's complement a few different times, but I'm not entirely sure why you would do it, so that's definitely going to require a deeper analysis. Oh man. Poor chat. Poor chat says, it took me a sweaty half hour to figure out how to do it on a piece of paper. I almost collapsed. +0 and -0 is the main reason. Ooh. I want to see this. What is negative? Let's see. What is -0 in binary? I've never had to do that before. I will admit. I'm not really sure what you would need -0 for, but I've got a lot to learn, so. Okay. So yeah, I would think it was just 0, because I feel like +0 and -0 is just the same, right? But yet again. Oh, but that's interesting though, because if it was -0, you do just flip all of it, which... But you have to add 1 at the end. Oh my gosh, that's so trippy. Wait a minute, what? Okay. Because yeah, with 2's complement, you flip it and then add 1, right? So that's why they say, that's a trick question. What? Oh my gosh. Okay. So Chad also says to avoid wasting code space on -0 and occupy it with a useful number. Yeah, that definitely makes sense. Huh. You know, I've never looked into that before. Thanks for bringing that up. This is really interesting. Wow. Okay. Also, if either of you haven't done choose comp, oh, that's the wrong screen. That's for tomorrow. That's the screen for tomorrow, not today. Not today, unfortunately. For a second, I thought it was Thursday though, and I almost tripped myself up. Okay, so yeah, if I were to do, this is hilarious. Let's do 0 just for fun. So yeah, I'll just do a bunch of zeros. This is positive 0 in binary. If I were to take 2's complement, I would need to flip all of these bits. So this would be 1, 1, 1, 1, 1. And then I need to add 1. 1 plus 1 is 0, carry it over. 1 plus 1 is 0, carry it over. 1 plus 1 is 0, carry it over. 0, carry it over, 2. So there is a negative 0. It's crazy. That's a crazy question. Wow. Also, I see another question in the chat that asks if I am still a uni student. I am still a uni student, and I've been one for a little bit too long, but that's okay. So it's kind of funny. I switched my major during my 3rd year, and so now I'm coming along my 6th year of university, and it is a time. I've been to a couple different ones at this point, so I'm hoping to graduate soon. But yeah, it's a journey, I will say. Okay, and then chat also says, yeah, to avoid wasting code space on -0 and occupy it with useful number. I never use it in my work because I'm a Java coder. You probably won't need it either. That's a good point. Very good point. Yeah, I feel like this kind of stuff is pretty useful when like working with things close to the hardware, especially with numbers. Like if you don't have a lot of memory to work with, the most efficient way you can do it, the better. So yeah. All right, well, today I'll be doing C++, again. However, I do want to say, so I did look at this problem before just to prepare a little bit. I had a little bit more extra time yesterday, so that was fun. But I did start with a similar approach where I have my logic and comments, and then we'll fill it out. And something I'm going to be using is the bitset library provided in C++, which is pretty cool because at first I was converting all my numbers to binary just by hand, which was fun because it turns out that a really fun way to do division is using the left, I think it was the left ship operators, which I found this resource that's really, really helpful if anyone else wants to look at it. In fact, I'll actually put it in the chat because it really, really helped me for this problem in the Twitch chat. So I'll go ahead and pin it too in case anyone else joins later. And then for the YouTube, my YouTube audience, I'll go ahead and post this in the YouTube description after the stream. If you're trying to look for it now, you could just use this title and you'll get to it pretty quick. Okay, so essentially what's really cool is that if you use a left shift, which is this symbol, you can literally divide the number by 2, which is really fun because it's a little bit more efficient, but again, it only really matters if you're trying to play with efficiency. So it's pretty cool. All right, so to use the bit set, I'm going to go ahead and I'm going to turn my start and goal integers into unsigned shorts, which, let me check my knowledge on this. So I think an unsigned short, I think that just means that we're making it into a number that can fill up to 16 bits, but let me double check. I'm going to double check that knowledge. All right, what is an unsigned short? I'm going to say in C++ because that actually might be important. Uh-oh, I accidentally paused my chat with scroll, which was kind of funny. Dang. Cool. All right, chat says, I don't think it's more efficient. Compiler probably turns it into the same machine code. Okay, that's fair. It's very fair. I'm not sure if that was for the 0 binary question or comment, or if it was for the division comment, but that's okay. We can test it. I haven't tested it yet, but I did read that like it could be more efficient, but I need to actually test it. So I think that would be good to check. So anyways, Okay, so unsigned short data type you can use in C++. It can store non-negative integer values. Okay, I know there's something that can do with the number of byte. Yeah, it was 16 bits. Okay, that's what it meant. Okay, that's what it was. So it apparently uses less memory than a regular integer, typically 2 bytes. Oh, that makes sense because an integer is 4 bytes, I believe. If that's incorrect, though, definitely call me out on it because this is based on old memory. Okay, cool. So yeah, that makes sense. So it can represent values from 0 to 65,535, which is literally 2 to the power of 16 minus 1. Okay, so essentially what we're just doing is we're just storing a number in a way that requires less bits. Okay, let's do the same thing for goal, and I have F in the beginning to represent final, so I don't lose track of my numbers. Okay, cool. Oh my goodness. Okay, sweet. Also, I just saw a bunch of okay, I think, were there any bits? I might have just missed that. Okay, if there were, thank you. Dang. Wow. Also, this chat is very active. Thank you all so much. This is fun. This is a fun day. Okay. Oh, yeah. Okay, so with the comment about not being more efficient, just turns into the same machine code, division by 2 versus left shift 1. Yeah, I do want to, okay, I will say I haven't tested it yet. So essentially what that does is it shifts the bit so that it just divides it by 2. But honestly, I mean, if we look under the covers of the division, it probably does the same thing. But I'm not 100% sure. So I feel like there's probably some truth to this. I'm actually really enjoying this this argument, by the way. I love it. This is great. Yeah, I really like that, actually. Because sometimes it's easy, like when you learn things on your own, it could be really easy to think that something is true, but if you haven't actually tested it or considered everything, like me, for example, it could be really, really easy to miss things. Okay, I'm going to go ahead and try to convert this into binary using the bit set module. Okay, so essentially, start bin also just stands for it's just short for binary. Okay, so I'm going to put my unsigned short in here. And I'll do the same thing with my goal. I'll put my final goal number in there. Okay, now I want to go ahead, I'm going to skip that part for now because I just want to go ahead and print this out just to make sure that it's working correctly. Okay, so this is my start number. And we're going to put my binary form in here in the stream. Cool. Apparently we have a LeetCode god in the chat. Hey! This is awesome. Oh, man. Honestly, all LeetCode gods are welcome in the chat. And I know I'm not perfect, but it's fun to learn live and learn together, though. Especially since, I mean, I'm very new to this, so, like, it's kind of embarrassing. I haven't done LeetCode for years, so this is fun. I feel like it feels like a good warm-up every morning. Okay, let's go ahead and run that. I just want to make sure that it's printing my my numbers correctly. I know it's a compiler. Oh, is it not going to let me? Oh, okay. I think it's just because I need to return something. Hang on. I'll just return 0 just so that it lets me compile. Okay. All right, that's fine. Oh, actually, hang on, there's an error here. So, use of undeclared identifier. Yeah. Why do I named this wrong. I went on autopilot again. This is what happens when I get up too early. It's not even that early. Okay, just a little bit of a name problem there. Wow. It's hilarious. Okay. Hey, at least I'm not typing what I'm saying out loud. Could be worse, y'all. Okay, so, yep, okay, we got our binary form here, which it looks like that is 10, and that looks correct. Okay, and then same with our goal of 7. That also looks correct because 2 to the power of 2 plus 2 to the power of 1 plus 2 to the power of 0. Yeah, that's correct. Okay, you get to see all my mental math. That would be a fun video. Mental math live. Oh gosh. Yeah. If there's a request for that, I'll do it, but I don't know if that's gonna be the best. Okay, so it looks like that's working correctly, which is good. Okay, now I'm gonna initialize a counter just to track the number of flips that I have to do, and then essentially what we're doing. This part's the easy part. So if we compare these, I'm just going to compare index by index, because when they're different, then I know that a flip is going to have to happen. So I'm going to do that in the form of a for loop. So we'll have, we'll do int I equals 0. We'll do I is less than 16, because there's 16 bits there. But we want to do less than 16 because the index starts at 0, so it's actually 15. Okay, so, and then I'll go ahead and increase I. Okay, perfect. Okay, now I'll do the if statement, where I'm just going to compare whether, I'm pretty much just going to compare if the indexes are equal or not, and if they're not, then up the bit flip counter. Okay, so if I do start bin, index I is not equal to goal bin, which bin just stands for binary. It's just short. Cool. And then we'll add brackets here. Okay, and then we will up the counter. And then we're going to go ahead and return the counter. Perfect. Okay, cool. So it looks like it's working with the test cases, which is really good. So yay! Okay, I'll go ahead and submit it. Oh wait, before I do, I actually want to cite my sources real fast. Okay, so this is my favorite part. Okay, so I'm always gonna cite ChatGPT for all. Sometimes it's conceptual, sometimes it's, I don't think we tested a line of code in this one, but the conceptual ones helped, like with the unsigned short explanation. It's September 11th, 2024. Okay, and then it was also, I'm also going to put developed with collaboration via the Pawsitive comedy stream, live stream, and the chat on September 11th, 2024. And then it was also referenced, I'll just put references, and then I'll go ahead and put this reference here because this was really, really helpful for me to just review how to use the bit set library. So references for bit set. Okay, and then chat says when they checked this problems editorial, their mind was blown. Ooh, you know, I don't think I even looked at it yet. Okay, I'm curious. I'm gonna go ahead and submit this. Let me make sure that I did all my comments right. Yeah, I did. Okay. I'm gonna go ahead and submit it. I want to see where it rates on efficiency. Watch it be like the last place. Could happen. Oh. Uh-oh. I didn't pass all the test cases. Oh no! Okay. That's a first. Hey, this is the furthest we got though. Okay, so let's see then. Let's see what happened. I love how it was somehow I got 7 and it was expecting 8. Okay, let's see what happened here. So 1, 2, 3. Wait a minute. Oh, this is trippy. Okay, so 1. Okay, how many 1s are there? 3, 4, 5. 4. Okay, 2. 3, 4. Okay. Let me look at this again. There's definitely something missing. Is it more than... Is that more than 16? Wait a minute. 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Oh. Maybe I have to do less than or equal to 16. Make sure it doesn't cause errors elsewhere. Oh, okay. That might be why it's one off. Nope. Really? Interesting. Okay. Oh, thank you. Okay, thanks, chat. Okay, so I'll use that test case. So start. I wonder if... Oh, you know what? What was the highest number for a unsigned short? I wonder if it's too low. That's definitely possible. 65,000. Oh no. Okay, I think that might be the problem because this is definitely higher than 65,000, which is not good. Okay, cool. Well, that's okay. Okay, I guess we're gonna have to adjust how we convert to binary then. Wow, that's fun. I wasn't expecting that. I think I might have missed the constraints. Let's say, yeah. Okay, that's fair. All right. Yeah, okay. Well, if there is a constraint with being less than 65,535, then this would work, but it doesn't, which is fine. I mean, honestly, we probably want a lot of test cases anyways to account for a lot of different approaches. So, you know, that works out. Also, I have a quick question for the Java fans in the chat as well, because I'm just curious. So, I know in my experience, at least, Java is definitely a language that I have the least experience with. The only experience I've had with it is in Minecraft, ironically. But I was just curious, like, if you learned it on your own or if you took a class, because I'm just super curious. Because I keep meeting a lot of people who haven't taken the class because it's not offered anymore. So I'm super curious. I know quite a bit of people that know Java, but those are people that went to university like 20 years ago. So I'm super curious. Okay, cool. So it looks like we have a lot of, yeah, we definitely have a lot of bits here. So I wonder if maybe just not having this constraint will help, because I'm not sure. It is possible that maybe, this is a little confusing actually. I want to see if this causes errors. I'm just kind of curious. Okay, actually it didn't. Oh, okay, so maybe I can just do the length of the number? I could probably do that. Maybe I can go until we reach the end, which I'm trying to figure out what the end would look like. I'm so used to the linked list now. Okay, so let's see. And then it looks like the answer to the question for our Java developer in the Twitch chat says non-CS self-taught through LeetCode. Oh, yeah, through LeetCode 150. Oh my gosh, I'm very familiar with them. I learned Java at university and Netcracker company courses and myself. Nice. Sweet. All right, I have a request in the chat to try 31. You know what? We'll give it a shot. Okay. Let's see what happens. Let me try 32. Oh man, okay. Let's see. It'd be really funny if I just added an extra to the counter. It worked for this test case, but not the other ones. Okay, so... Oh, maybe 30 because... Okay, I'm not really... Okay, we can try that. I'm not entirely sure about that, but we can... You know what if I just did something crazy and just went to 100? I don't think this is... Now I just feel like I'm hard... Yeah, okay, that's what I thought. Okay, what if it was 64? Okay, that's just wrong all around. Wow, dang. Okay, well, we're definitely gonna have to change our approach here. Because yeah, 16 isn't enough, which is fine. So we just have to figure out what number we need there instead. Okay. So, we're probably going to have to... Oh, actually, you know what? Okay, chat made a very good point. So my bit set was set at 16 at the beginning. Okay, let's try 32. Let's see if I can change this to 32, because I can make this bigger, I believe. I actually haven't done that before, so we're going to find out. Okay. Interesting. It's still saying 7 for some reason. I'm curious to see. Okay. I feel like we're so close. Oh, okay. We gotta love it though. This is how it is for computer programming sometimes. All right. Well, I think everything should be fine. Okay, here. I saw another question in the chat too, talking about the XOR operator. I will say I have used that one before. I've used it in assembly. I have not used it in C++ before, so that would definitely be an experiment. But it's definitely worth. That's definitely another approach that's worth trying. Okay, I'm trying to think what length this is. Okay. 3, 4, 5. Yeah, this should be 32 here. 1, 2. Yeah, okay. Interesting. Yeah, I feel like, okay, so chat's also making a really good point too about the short hold value. This honestly might have a problem. Well, I could try making this, okay, so we might, if we do change this, we'll probably have to change how to use bit set, because I think I need to look back at the parameters for this on what it can accept here. Because I know it can accept a short, but yeah, a short is going to be... What if I did a long? Would that work? Let's see. What? Wait, what? Okay, hold on. Hey! Woo! Oh my goodness. Okay, that is hysterical. Well, I guess we just had to use a long instead of a short. Thanks, chat. You made a you made a very, very great point there. Yep, that makes sense. Long is 64 bits, and then, yeah, the short is definitely shorter. Our unsigned was just short. Okay, also, what? Holy cats. I was not expecting that at all. What? Okay, but its memory isn't great. Look, oh, okay. Well, that's great. But that's fun. Okay, honestly, that's pretty cool. Wow. All right. I'm happy with that. This is the first, yeah, wow, this is the first time we had a stream where we actually finished it. So this is crazy. Okay, wow. Thank you everyone in the chat too. This is fantastic. Also, I think Nightbot went on attack mode on one of my chatters. I am so sorry about that because you were literally just celebrating and it deleted your message. But anyways, so sorry about that. You definitely were fine, but this is definitely a cause for celebration. So we're gonna have a little bit of confetti and we're gonna have a dancing Steve to celebrate. Woo! Oh my gosh, that was honestly very, very fun. Thank you everyone for your support in the chat too. This is an adventure for all of us, so I really appreciate it, and I hope you got something out of this as well. I'm excited. So this is our, I won't be doing any more LeetCode challenges for the rest of this week, but our next stream is tomorrow from 6 to 7 PST. I'm doing Roblox game design, and then from 7 to 8, I'm doing Minecraft mini games. And then our next LeetCode challenge will be next Monday at 10 a.m. All right, so I do have to go since I'm past the 30-minute mark, but there will be more LeetCode challenges in the future. If you end up doing more throughout the week too, feel free to hop in our Discord channel because other people will probably be doing that as well, so you all can help each other out there too. All right, have a wonderful rest of your day, everybody, and if you're coming to the stream tomorrow, I will see ya. Bye-bye.